Hello, everyone. Thanks for coming along. Let's give another minute or so for people to join in if there's a few people still waiting to join. Okay, looks like we've got a good amount of people on, so I'll get started. So first off, hello everyone, and welcome to today's Immersive Labs live demo session. Thanks to you all for coming. It's great to see everyone here. This time we'll be covering our new C++ beginner series, which was released about 2 weeks ago now. We'll be giving you a quick run through of what the labs look like, as well as some insight on our objectives when creating the labs themselves. To quickly introduce myself, my name is Will Roberts. I'm a junior application security engineer here in the AppTech team at Immersive Labs. We make the secure coding labs here, as well as some of the other categories such as secure ops and secure tooling. So before the presentation begins, I'll go over some housekeeping quickly. So first of all, the session is being recorded, and the recording will be available on our YouTube channel, as well as on the platform and on the website. So if you miss anything or you'd like to rewatch it afterwards, you can find it there. As well as this, you'll be emailed a link to the recording, I believe. So again, you can watch that back anytime at your leisure if you want to recap on any part of this. We've got about 30 minutes in total here allotted for the webinar. I will make sure to leave some time at the end for questions towards the end of the session, but do feel free at any point during the session to type in any questions. I can see them up here on the left, so I'll try to get to those as and when they come up. But if I do miss one, I will try and get back to you either at the end or I will email you after the session if it's something that I can't answer right now. Of course, this is a live webinar, and like many live sessions, it can come down to things like my broadband speed or connectivity. So please do bear with me if anything happens there, but fingers crossed it should be all right. If anything happens on your end when it comes to connectivity, if you accidentally get disconnected or logged out, then just click on the same link that you used to initially join, and you should be fine to rejoin the session now. So I'll get started now. So before we get into the labs themselves, I'd like to first give a little bit of context to the webinar, as well as a summary of our application security product at Immersive Labs for those who maybe haven't got a license or haven't tried the AppTech labs specifically. So first point, why do we need it? Application security in general. Well, I think for those who keep an eye on cyber-related news or just the news in general, you probably already know the answer to this one. Because it feels like every week we have some front page story of another billion-dollar company getting compromised in one way or another. And you will find this is often through vulnerabilities in user-facing or even internal applications. So ensuring the security of the applications themselves is paramount to avoiding these kinds of situations. The consequences of such attacks can be very broad. It ranges anywhere from user data leakage, which is, again, not a great thing since the GDPR regulations came in. It can be very costly and, of course, damage the reputation of any business that leaks some user data. And things like this can happen through vulnerabilities like SQL injections, giving access to the databases from an attacker point of view, which is never good. Sensitive information disclosure, so things like company code, company secrets, things that you don't really want attackers to be accessing, maybe internal stuff. We want to avoid that as much as possible, of course. We want to keep those things locked down where we can. And in the worst cases, even compromising users' systems can occur. So if you maybe distribute an application or a piece of software and a user uses this and it has some level of vulnerability in it, then the user kind of takes on that responsibility at that point, and it can look very bad on the distributor of that software if there's some kind of vulnerability in there that puts a user at risk. Now, there is some level of awareness around these kinds of things. So I'm sure you've heard of bug bounties before, where hundreds of thousands are spent on paying individual software security researchers and people like that to find bugs and report them ethically. these programs are really good, and it's good that they're becoming more and more popular, but they're not always a silver bullet when it comes to catching vulnerabilities in software. What can often happen is places like black markets online or like underground scenes can often offer much more in terms of monetary value. They can pay much more for these vulnerabilities when compared to the companies themselves that run the bug bounties. So if you look at companies like Google, who offer tens of thousands of dollars for some vulnerabilities and stuff like the Chrome engine, you'll often find these for much more on the black market. You could for 6 figures plus. So it's definitely not always a great way to deal with it. What you want to be looking to do is including the bug bounties, but as well as that, having a strong application security foundation during your development, so you know how to avoid those in the first place. When it comes to application security, it's not always a lack of awareness, but also a lack of resources and commitment to it. So we recently did a joint research project with Osterman Research. They produced a white paper, and some of the findings for that were really interesting. So what was found there was that a combined total of 81% of DevOps employees have knowingly released vulnerable code. So the word knowingly there is very paramount, as you know, I'm sure a lot of companies have released vulnerable code at some point, but it can often be assumed that this is unintended and maybe didn't know about the vulnerability, but knowingly releasing vulnerabilities is an entirely different issue. This kind of thing can be down to companies maybe not giving enough time to developers to fix these kind of things, or not giving enough training in the first place. So when it comes to this, we need to think about taking care of every step of the SDLC, the software development lifecycle, and doing something called shifting left, where we take into account the importance of thinking about application security and giving the time and resources needed to fix these vulnerabilities before they can be released. So up next, we want to know who's involved in handling things like this. So there is the old mindset of security being left as a job for the cyber geeks, the guys maybe in the basement who are the ones handling all these kinds of things. But oftentimes this can even be left up to one person in smaller companies. So having the entire cybersecurity of a company on the back of one person is, you know, you can kind of imagine it's not the greatest idea in the world. So at Immersive Labs, we firmly believe that this is not the way to go, that it shouldn't just be left to the security team. So we believe that security should be a responsibility at every level. So ranging from the most junior of developers who need to be trained up, to the technical managers who can oversee developers and maybe choose where the time is spent and whether to shift left or not. And even C-level executives, we want them to have an understanding of security as well, so they can kind of empathize when it comes to looking at delaying things. It can't just be the developers on this as well. They need the resources and the time allocated to these things. So even if you have developers and you tell them to train or to be security aware, they need to be able to have the resources to be able to do so. When it comes to that, education and training is of course vital when it comes to helping at every level, but especially developers. So how can Immersive Labs help? Well, when it comes to application security, we try to provide opportunities for developers to upskill through our AppSec Labs. So we kind of want to be the role of the helping hand given to developers once the time and resources have been granted to them to kind of learn and improve in these areas. We've recently reached a pretty huge milestone for the team, for the AppSec team, by adding our 200th AppSec Lab to the platform. This is across a wide range of categories. So secure coding is our biggest one, where we cover multiple languages at different difficulty levels. So that covers things like Java, Ruby on Rails, Python, C#, PHP, and many more. And C++ is one of the latest offerings in that. We're always looking to expand our breadth to fit the needs of as many customers as possible. Now I can hear you say that's all well and good, but the obvious next question is what makes us different from picking up maybe an online course, maybe reading a book, going to an in-person course, something like that. Well, I know at least for me personally, the biggest difference when using the platform has always been theory versus practice. You can read about things in theory for as long as you want. You can read 100 books, but there's always going to be that element of needing to actually try something to fully understand it. Learning about these things can be really complex. It can kind of cover things that you wouldn't usually think about from a programming perspective, as attackers do often pick apart code in ways that you wouldn't think of at all. So when it comes to things like that, being able to look at code specifically, remediate vulnerabilities, and point them out where you can is going to be absolutely vital in getting a full understanding of where that happens. So our platform, we try to strike a nice balance between guided learning and using your intuition and problem solving. So at the lower levels, when we have the beginner labs, we like to provide as much information as possible, have a nice briefing section so you can fully understand the vulnerability, go through it, fix some vulnerabilities, but have the option for help if you need it there. And then when we move up into the intermediate and advanced labs, there's going to be less and less kind of assistance available, and it's going to be more relying on the intuition of the programmer implementing the knowledge and the skills that they've picked up from the rest of the labs. Another thing we like to focus on is the impact for developers. So in isolation, if you're just learning about a vulnerability, you can think, okay, great, I know how to fix this, but what does it mean? The impact is lost. So the way we try and avoid this is by showing at every step what can happen if these things are maybe not considered as much as they should be, or not given the gravity that they should have. One way that we've recently done this is by launching a feature in some of our Python labs, and I think it may be in some of the other series as well now, where you can press a button in one of the labs and it will take you step by step through in front of you an attack as it happens. So it will go through step one of exploiting the vulnerability and then showing the results of that, showing what can happen, potential payloads, things like that. And it's a great way to really gain an understanding of the impact of what can happen if you leave applications insecure. So if you want to try that out, I definitely advise going on Immersive and trying on one of the Python labs, as I believe they will have that feature implemented now. Finally, we have an important distinction to make in that we don't actually teach you how to code per se, but it's more teaching you how to code securely. So we kind of have an expectation that the developer already knows how to code at a decent level, but they maybe don't have as much of a grasp on using secure coding and knowing where to look for things like that. So we often get questions like, why don't you do the whole thing? You're not missing a trick here, but we think by focusing specifically on the coding itself, the secure coding itself, we can create a much more refined product and create some really high quality stuff rather than spreading ourselves too thin. So with that out of the way, we can move on to the C++ series itself. So for the beginner series, we've got 10 labs in total. One of these labs is a kind of introductory lab that helps the user get a feel for the series. It shows them around, shows them how everything works. And it's great for those who maybe haven't done our secure coding labs before or haven't used them too extensively. It shows you around what to do exactly in each tab, and then it should give a great way to kind of segue into the rest of the labs. We estimate it should take about 2 hours and 35 minutes in total to complete. This is going to vary depending on who's doing it. Of course, it's going to be a variable how much content they want to read, how much more research they want to do, how skilled they are already. But we think 2 hours and 35 minutes is a reasonable estimate. And then the difficulty level is a 3 to 4, which most of the beginner series are when it comes to AppSec. So this is, we expect the user to have some level of coding knowledge already, but they are maybe just getting into the secure coding part, and they would like to have more of an understanding of how to code securely, so that we're giving them the first steps there. So now I've got a demo here. So here I'm on the Immersive Labs categories page. So you can access this from the home page by going to Browse and then Labs by category. This page will get loaded up, and then up on the left here, we have the Application Security tab. We just click that. Scroll down to the C++ beginner series. You can see it here, along with all our other series. And here we display it with all of the labs. So as you can see here, we've got the introductory lab, which goes through the lab format itself. And then we have 9 labs covering vulnerabilities that we felt were appropriate for beginner level C++ users. So these are going to mostly cover vulnerabilities from stack-based things within C++ for developers. So these are going to be things that you may encounter pretty often when it comes to things like buffer overflows and format string vulnerabilities. But it's also going to be things that you maybe wouldn't think of as much. So stuff like out-of-bounds array access and even SQL injection can occur in C++ programs. So we wanted to have a good balance of vulnerabilities that you find often, but also ones that are easier to understand for those who are just getting into secure coding. So I'll just boot up a lab here to show you the format. Once you click here, you'll have a small introduction summary on what the lab is, what the specific vulnerability is about. You have some learning outcomes for what the users should expect to learn from this, and also what's involved to show what they need to do within the lab. Up here, we can click to boot up the lab, and we are brought in here. So it's all based within the browser. You don't need to download anything. We'll just we have everything here in front of us. On the left, we've got our tasks tab, which will guide us through the lab when we want to get to actually fixing the vulnerability. So we'll go step by step. And on the beginner labs, this is provides quite a lot of information, but it will be less and less information as it goes to intermediate and advanced. So in the briefing, we are going to have all of the information, the text-based information that is needed for the lab. So these individual paragraphs are going to be really useful for the developer to gain a more text-based theory understanding of the vulnerability for that specific lab. So things like the summary, giving an understanding of the vulnerability from a high-level point of view, going down to the prerequisites, what the developer should know before they attempt a lab about the vulnerability, where we try and do a deep dive into the specific vulnerabilities for this lab, going through a small write-up on it, as well as providing stuff like code examples and shell output for specific running of code. Down to the impact, showing you what can happen if you don't remediate this vulnerability and it's left within a program. The remediation section that teaches you how to actually fix the vulnerability. Again, providing a code block, which is similar to the one in the about the vulnerability section. And then we get to detection, which tells you how to find these vulnerabilities before they make it into the code or before they get released into production. So doing things like using DAST and SAST scanners to pick these up, and also listening to the compiler, looking at any warnings, things like that. Next up, we have a real world example, which is another thing we focus on when looking at the impact side of things. So we want to give an example of where these things can happen in the real world. So for this lab, we've got one for the sudo exploit, which was publicized in January, which is quite big. Sudo is a very popular program on Linux, and an exploit in this program could be used to gain some privilege escalation from an attacker point of view. So that's an example of how it can happen. And then the last two sections we have in this lab, which shows what specifically links the lab to the content here, so what the user will need to do. And then further reading, where the user will be able to click on some links to read up more if they wish. Coming back to the top, we have the preview tab. So C++ labs are a bit different to the secure coding or the other secure coding labs that we have at the moment, in that the other secure coding labs will focus around a web app that you edit directly. This one, we have a kind of intermediary web app that is used to display the output from the command line, as often you won't have a web app for things like C++. So we have three tabs here. One is for the compilation, to make sure the program compiled correctly. The next one is to ensure that it works correctly. So this will show the output of a script running the program as it's expected to run. So you can kind of debug using the output from here. And then similarly to that, we have the secure tab, where again, an automated test will be run, and you can check the output to see what is happening. As we can see, there's a line at the bottom here that we'll look back to a bit later to try and debug. So we've got two of the boxes ticked off here. We want to take off the third one to ensure that it's working and secure. We can then move on into the code editor. So this is kind of similar to what developers will be working with day to day. It's called an IDE, or an integrated development environment. They'll be able to edit any of the code they want to here. So they can scroll through the source code, read anything they want, drop down into folders. It should be a very comfortable experience from them, and it should have many of the similar things they used to when coding normally. So they can choose to edit whatever they like. The way that you kind of work on things like this using the integrated development environment is changing code where it's needed. So we can intentionally cause an issue here. So if I type in something here and then run a test in my code, you can see this updates at the top. So it's telling us it's not working anymore. We can refresh and see that the application failed to compile. The user will then be able to drop down, see what's gone wrong, check which file has the error in it, check which line number has the error, and have a similar kind of experience as to how you would debug a program normally. So then they can go back into code editor, remove the issue, test that code again, wait for the few seconds to verify, and go back to the preview tab, and it's all good. So from a developer's point of view, how they would like to go through the lab is first go through the briefing, read as much as they can about this, gain an understanding of the vulnerability, learn how to remediate it. Those are two very important sections. And then they'd like to go to the preview tab, read along the tasks on the left, see what they have to do, maybe have a look at the output, see if they can spot anything going wrong. Go to the code editor, see what they can edit here. As it says on the left, we're looking at the dbfunctions.cpp file on line 40. So we've got that here. They can see that there's a line here that's out of place, but they may not be 100% sure what's wrong with it. If we compare it to the code in the briefing, we can see there's a similar line here. And then if we understand that, look at the remediation, we can see that this bit has been changed. So if the developer then understands that, they can go into the code, change that as needed, insert a fix that they feel is appropriate, run test my code. And then after a few seconds verification, it's all ticked off. And then a few seconds after that, the lab completes for them. So that should be the experience that they have. They can then move on to the next lab, go straight on, continue doing labs for as long as they like, or they can exit, go back and recap. So that's a kind of a standard experience that you have with the C++ lab. Moving on from that, we can have a look at what's actually coming up next within the AppSec team. So when it comes to C++, we are looking at creating intermediate and advanced series for these. So when it comes to things like heap exploits, memory management issues, these are more complex vulnerabilities that were maybe not covered as deeply in the beginner series, as they would have been a bit too much for that. We're not 100% sure when these will be released, but as always, we respond to the demand of users. So if the C++ series is something that you're enjoying, if it's something that's coming in handy, then let us know about it so we can prioritize more labs coming up with that. For other languages, we've had some Go labs recently drop, so those came out a few days ago. We've had some good reception on those so far. So again, our language choice is always expanding, and we'll be looking to release some of those more in the future, hopefully. Apart from that, we have some secure ops stuff that has come out recently. So we've had our Apache series come out that will teach users how to correctly configure Apache, look at common misconfigurations that may lead to unintentional exploits being available to attackers. So that'll be good for the more DevOps side of the team. And then, as always, like I said, we respond to whatever demand is being expressed at any moment. So if there's something that may fit you better than what's already on the platform, then make sure to let us know about it. We're always happy to hear. Quickly about the next webinar, we have another live demo coming up about containers and infrastructure code. So this will be from the cloud team, I believe. As you can see there, it's up on the 16th of September. So make sure to sign up for that if this is something you're interested in. It covers container handling, some of the stuff from the NSA that I believe came out recently, where they gave some advice on container handling. Make sure to register for that if you're interested and have a look at it. Finally, I've left some time for some questions. Apart from that, thanks for watching along. I hope it's been useful. If you're interested in the series and you have a license already, make sure to hop on the platform, have a go. All the labs are available at the moment, so you can just navigate to them as I showed you earlier through the categories and try them out there. If you don't have a license currently, make sure to go to our website and send an inquiry there, and we'll have someone help you out, see if you can have a good fit. And apart from that, any questions, if anyone wants to ask, I'll be happy to answer. But apart from that, thanks for watching.